Once upon a time, there was a tiny neglected plant. A plant capable of working wonders. An ingenious and resilient plant. Long underestimated, it is a plant that excites the passions of the scientists working to unveil its mysteries. It grows everywhere on the planet. It transcends the landscape and gives us a glimpse of surprising, magical worlds. This small organism tells a marvelous story about our world. Mosses are essential to life on Earth, and they have been reshaping our planet since the dawn of time. In Japan, mosses are revered. The Japanese look upon them as Westerners might look upon a heavenly constellation, with the same awe and wonder. Here, the forces of nature, such as the wind, the rivers, animals, and moss, are venerated. They are careful not to disturb the plant and let it cover sacred sites. They care for the mosses with endless skill and patience. They go out of their way to protect and contemplate the mosses. Every detail is important. Anything that might disturb or harm the moss is meticulously removed, as if each sprig were a priceless treasure.
古来から日本だと日本の庭園の中に大きな世界を凝縮する、それが禅の世界であったり、これはおそらく日本人が自分の身近に理想とする世界を作ることで精神的な安定感を得ている。そのために苔って見ると単一な緑、花のように色鮮やかなわけじゃない。でもその単一な緑の中に自分の心を癒してくれる何かを見つけた時に、その不完全な美が完全な美になっていく。それがまた苔の持つ美しさの一つの意義なのかなと思っています。
The Garden of Kokedera, also known as the Moss Temple, is an extraordinary sanctuary. It is home to more than 120 species of moss. Unlike the complex Latin names used in Europe, the Japanese give mosses more delicate, intuitive names like spiral moss, whip moss, shining branch, white hair, and grandfather's beard.
例えばこの庭園で見られる苔にも動物の名前を冠したものが多く見られます。代表的なのがヒノキゴケ、別名イタチの尻尾と言います。これはイタチの尻尾のように柔らかい形を例えて名付けています。またこの庭園には、低湿度が高いところが非常にたくさんある。そうした場所にはカビゴケというとても面白い匂いを出す苔も見られます。
Mold moss is very easy to locate. All you have to do is bend down, take a sniff, and let yourself be guided by its characteristic odor. Other mosses give off the aroma of peppers, cucumbers, or oysters. In this temple, each sprig of moss is treated like a precious jewel, fragile and delicate. But there are other, less hospitable places where the mosses can show off their exceptional capacities for survival. The volcanic highlands of Lakagiga in Iceland reveals some of the superpowers of moss. How did our frail little mosses manage to invade these lunar landscapes scorched by lava flows? In 1783, one of the most violent volcanic eruptions of the last 10,000 years happened here. Magnia Magnusdottir is an enthusiastic biologist. She is studying the grey, velvety moss that covers the surface of this area, the Raccometrium.
Hraungambri er oft landnemi á hraunum og mjög algengur í hraunum og vex í mjög víðáttamiklum breiðum í hraunum. Og hann er mjög þurrkþolinn og getur þolað að lifa á svona svæðum, á svona erfiðu svæði. Hann hefur til dæmis hárodda á blöðunum sínum sem hann hjálpar til við upptöku á vatni. Þetta nýja landslag, gígarnir og hraunið, það er náttúrulega algjörlega næringarsnautt og mjög erfitt landslag, erfitt yfirborð fyrir lífverur til að nema land. Mosarnir, þeir eru ekki með eitt rótakerfi og þeir geta tekið upp næringarefnin í gegnum yfirborð frumnanna sinna, yfirborð líkamanns, næringarefni og vatn í gegnum það. Þannig að þeir geta vaxið á steinum og þeir þurfa ekki að bora rótunum sínum niður í gegnum neitt eins og moldi eða svoleiðis, heldur þá geta þeir bara krækt sér, farið von í hólur og krækt sér fasta með svona rættlingum og þeir geta líka vaxið á annan hátt heldur en háplönturnar vegna þess að þeir geta vaxið bara með því að lítið mosabrót fýkur í vindi, lendir lítil í hólu og það geta að byrja að vaxa. Þessi mosi sem er hér, hann er 230 ára gamall. Hann er búinn að vaxa og verða þetta þykkur á rosalega löngum tíma. Þannig að þess vegna þessar mosaþembur svo rosalega viðkvæmar og við þurfum að vernda þær svo vel. Við megum til dæmis ekki bara traðka og eyðileggja þær af því að þær eru svo rosalega lengi að vaxa og verða svona þykkar og fallegar.
It has taken over 2 centuries for nature to produce this fragile coat of moss. 60 centimeters thick. It covers this vast, 10-meter-high lava field. Over time, the moss has grown thicker. It has created a fertile, stable topsoil that allows flowering plants and shrubs to grow. The moss is a pioneer plant. It has taken hold where no one expected it to, in this harsh, inhospitable landscape. To understand how that was possible, we have to go back to a key moment in our planet's history. 450 million years ago, the oceans underwent an enormous upheaval. Algae took advantage of the tidal ebb and flow to move onto the land, gradually adapting and evolving into mosses. Their spread provided a layer of soil over the volcanic rock. These very first terrestrial plants were one of the main sources of oxygen in the atmosphere, enabling other forms of life to evolve and thrive. Mosses have colonized nearly the entire surface of the Earth, transforming an arid planet into a lush planet. Mosses grow nearly everywhere on the Earth. We have discovered close to 25,000 species. The conditions in the gorges of the Tŵr Gulic in Brittany are ideal for mosses. The light is filtered by leafy branches, and it is always humid. Moss grows everywhere. Moss specialists, or bryologists, come from near and far to study these mosses, or bryophytes. Vincent Huguenot is one of France's leading bryologists. He never goes anywhere without his favorite tool.
Sans loupe, on est un peu perdu en tant que bryologue parce que ce moyen optique permet d'observer des caractéristiques comme des petites dents sur la marge des feuilles, la présence d'une nervure. Ces petits détails anatomiques qui sont peut-être insignifiants sont en fait d'un grand intérêt pour commencer à proposer une détermination sur le terrain et se dire bah tiens, cette espèce présente peut-être un intérêt, je vais la collecter puis je vais aller l'examiner au laboratoire. Je suis intéressé par la botanique depuis l'âge de 8 ans. J'ai commencé évidemment comme tous les botanistes à m'intéresser aux plantes à fleurs parce que c'est des végétaux qui sont de grande taille, peut-être plus faciles en première approche à étudier. Et puis peu à peu, je me suis intéressé aux bryophytes parce que c'est des végétaux mal connus, qui ont très peu d'adeptes en France. Et on peut faire des découvertes assez extraordinaires, peut-être plus facilement que chez les plantes à fleurs. C'est un peu de l'ordre de l'aventure et du magique peut-être.
Grasping the beauty of mosses is first of all learning how to look at them. Observing them reveals surprising and widely varying forms.
Les bryophytes vivent imbriquées les unes dans les autres et elles forment une espèce de tapis assez homogène. Certaines sont prostrées, rampantes, très ramifiées, d'autres sont dressées extrêmement raides, d'autres sont minuscules, colonisent les aspérités de la roche, d'autres vont former des boules énormes. Et cette variété de formes, c'est ce qui permet aux bryologues de les repérer, de les nommer sur le terrain.
Because what bryologists like best is recognizing and naming mosses, detecting the rarest species, and immersing themselves in anatomical detail. Close observation of the mosses transforms them into lush jungles, inhabited by fantastic creatures. An invaluable network of living beings which spread, decompose, and regulate the microflora of the ground. These miniature forests are home to crawling springtails, curious hairy moss mites, and slimy roundworms. If we look even more closely, we can make out these unusual microshrimps called rotifers and strange little 8-legged creatures that browse on the surface of the mosses, tardigrades or water bears. These amazing creatures are quite resourceful. They can slow down their metabolism to withstand drought, a fascinating adaptation that they share with mosses.
Les bryophytes ont une capacité extraordinaire, c'est de se mettre en sommeil, en dormance, pendant une période qui peut aller jusqu'à des dizaines d'années. Une mousse qui entre en dormance commence par se déshydrater, se recroqueviller sur elle-même. C'est d'abord les feuilles qui vont se tordre, se friser, s'enrouler en spirale autour de la tige. Elle se déshydrate jusqu'à un point extrême pour protéger les cellules encore vivantes qui sont au sommet de la plante et qui vont, dès que la pluie va revenir, permettre la reviviscence. En quelque sorte, la mousse va ressusciter, elle va continuer à croître. En quelques heures, elles sont capables de renaître à la vie et de continuer leur croissance.
This heightened tolerance to drought and the moss's capacity to revive when conditions become favourable again are major assets. They allow mosses to withstand extreme conditions better than any other plants, even in the harshest environments. A British ecologist came face to face with this phenomenon called reviviscence on an expedition to the South Pole to study global warming. This is Peter Convey. In 2014, he revived a moss plant embedded in the frozen soil. His discovery sent a shockwave through the scientific community.
What we were trying to do was to sample a core through one of these deep peat banks. So several cores were taken to be analysed for various chemicals that are indicators of climate. But we took an extra core simply because we wanted to analyse the biological properties of the core itself. So not the chemistry, not the climate reconstruction. We simply wanted to see, was there any life within the core itself? We wrap it up carefully and cleanly, we pack it into boxes, and we carry it around about an hour and a half's walk back to the station where we can put it in freezers. And that's all we do with it on the station. We store them in freezers until we can get them back to the UK.
Peter Convey came to analyse the soil chemistry. This moss sample was not the primary focus of his expedition. But because he was interested in the characteristics of bryophytes, his attention was drawn to the exceptional thickness of the moss sample he took.
We have a very clear clue that these moss banks are old. For the very simple reason that in the Antarctic, mosses grow about 0.5 centimetre a year. So if you've got a 2-metre thick moss bank, you've got many centuries of moss at the bottom. You know it's going to be old. The only way to test how old it is to use radiocarbon dating. So the key thing, if we know we've got 1 metre of moss, we had 1.5 metres of moss in this core, we know that the bottom of that is many centuries old. So the next question was to find out how many centuries old.
The thawed-out moss immediately showed signs of life, and thanks to carbon-14 dating, Peter made a remarkable discovery. He had revived a 1,500-year-old moss. It was around when the Roman Empire was on the decline.
I was rather excited. I mean, it was a brand new discovery. This moss was happily growing away on Cygne Island millennia and a half before we discovered Antarctica. It's a step change in our understanding of how long something can survive for. It obviously was alive. We haven't created life, but we've stimulated it back into growth. And it's by far the oldest one I'm aware of that's happened to, yeah.
Could it be that mosses have discovered the secret of immortality? What is for certain is that they are still full of mysteries. And what about these colonies of moss called glacier mice? They can survive on ice. Their most surprising characteristic is not their tolerance to the cold, but their capacity to move 2.5 centimeters a day. Neither wind nor gravity explain this phenomenon. So how do they do it? One explanation is that our glacier mouse protects the ice beneath it from the sun. When the ice around it melts, the moss is left perched on a little ice island it has protected from the sun's ultraviolet rays. It eventually tips over, and the process starts again, slowly transforming the moss into a rolling ball. So much for the old saying, a rolling stone gathers no moss. Mosses are discreet, but grow all over the world. They can cope with extreme temperature swings ranging from -40 to +70 degrees Celsius. Bryophytes include mosses that can survive in the hot springs in Iceland. Like this moss, the Solenostoma, that clings to rocks in scorching Icelandic rivers. Bryophytes are one of the organisms most capable of adapting to climate change. How can a plant be so resilient? How has it managed to grow everywhere on the planet? What is its secret? The moss's extreme resilience lies in its simplicity. It is an organism that has no flowers, no seeds, and no roots. The moss does not draw the nutriments it needs from the soil, but from direct contact with air and water. A few drops of water are enough to trigger the moss's reproductive cycle. Water activates the spermatozoids, which swim to the female gamete. Fertilization takes place, and a fairy-like ballet begins. After 3 weeks, the miraculous cycle of life gets underway. Long filaments rise towards the sky. They are topped by small pods, which swell and open. They explode, releasing thousands of spores, like a firework display, giving life to a new generation of baby mosses. Mosses have retained features inherited from their aquatic origins. As they evolved, they survived on a planet with no atmosphere, bombarded by the radiation from the sun and space. This could help explain their resistance to the radioactivity in the contamination zone around Fukushima in Japan. Professor Masaki Shimamura is the director of the Biological Society of Japan. He has been studying the impact of the nuclear catastrophe on mosses.
私、広島大学に所属しているんですけれど、広島は1945年に原子爆弾の被害を受けました。その時、実は人間はもちろん他の生き物に対する影響がどういうものだったのかっていうのは実はあまりよく調べられていなかったんです。今回の事故について考える時に、できるだけ事故が起きてから、すぐに調査を始めて、苔植物を含むいろんな生き物に対してどういう影響が起こるのかっていうのは、苔植物は先ほど申し上げたようなセシウムのような放射性物質だけではなくて、さまざまな金属などを蓄積する能力があります。今、測定した限りこれぐらいの放射線量でしたら苔植物にはほぼ何の影響もないと思います。苔植物の成長には何の影響も見られない可能性があります。
This bioaccumulation by the mosses has led Professor Shimamura to conclude that the forests and dams are the most contaminated areas. Rainwater soaks down to the bottom of the valley, where record levels of radioactivity can be observed. The radioactivity is then captured by the mosses. Lacking the protective cuticle found on the surface of most plant leaves, the water is absorbed into the interior of the moss, which then stores the contaminants. Bryophytes are very sensitive and respond quickly to environmental changes.
で、人間に対する影響も大事ですけれど、その自然生態系だとか一つ一つの生き物に対する影響っていうのも見ていかないと、その壊されてしまった生態系が今後どう直していけばいいのか、どういうふうに治っていくのかっていう、そういう理解を深めていくためには必要なことだと思っています。
Mosses are reliable early warning systems, which allow us to measure the quantity of radioactive pollution in contamination zones. If their DNA is damaged by pollutants, they continue to develop, even after a nuclear catastrophe. But that is not all. Mosses can also auto-regenerate from a piece of stem or a damaged leaf. This miracle is possible thanks to a cell only found in ferns, algae, and moss, which is capable of reprogramming itself very quickly, like a stem cell.
狭い範囲に生きているもの、一本一本の苔に私たちは見えますけれど、それはひょっとしたら一つの個体かもしれませんし、その個体っていうのは妙によっては、もう一つ苔植物は体の先端部分に長端細胞という特別な細胞があります。で、そこから植物を どんどん繰り返し茎や葉を作っているのですが、それ以外にも葉っぱがちぎれて落ちた場合にもまたそこから、新しい細胞が分裂した時にまたそこに長短細胞が生じて新しい植物を全く自分と遺伝的に同じ植物を繰り返し作ることができる。
Like the heads of the mythical Hydra, each tiny ripped-off fragment of moss can give birth to multiple autonomous clones. A major asset when it comes to expanding and conquering new territories. But this depends on our little moss encountering no new pollutants. Otherwise, it can become very vulnerable, like here in Iceland, near this geothermal plant that uses volcanic energy to heat the capital, Reykjavik.
Í gufunni brennisteinsvetni sem getur myndað í raun og veru svona súrt regn í gufunni og þegar það rignir niður þá það súrt regn. Svo það líka bara sjálf lofttegundin sem hefur áhrif á mosann og þetta gerist þannig að gufan stígur upp í loftið og svo strengjur hún sér niður og lendir á mosanum og þetta heitir Gaussian plúm, það sem fer upp og kemur svo niður cirka kílómetr frá tökunum.
To withstand the poisonous Gaussian plumes, the mosses need help. Magnia has come to their rescue with an original recipe. It took her several years to perfect it. First, pick sprigs of moss, taking care not to leave any holes. Place the moss in a container and carefully disentangle it. Roughly cut the moss. A garden strimmer may be used. Pour in gallon after gallon of fermented milk and stir thoroughly until you have a unique moss soup.
Pínulítið brot af mosunum, jafnvel 1 lítið blað eða brot af laufblaði. Ef við dreifum því þá vex bara nýr mosasproti þar upp. Þannig að hann vex með svona klónvexti, mosinn. Og við notum okkur þessa dreifingar tækni mosans til þess að endurheimta hann. Þannig að við dreifum í raun og veru svona litlum brotum af mosanum, tætum þá niður í mosahræringin og þess vegna getur þetta nýst á miklu stærra svæði heldur en við myndum bara dreifa þessu beint hérna. Þetta getur nýst á kannski 10-falt stærra svæði. Eða þú veist, bara eftir hversu þið nennið, hverju þið nennið.
The mixture is transported to the site of the damage and applied by hand. A milky crust develops, holding the chopped sprigs in place, and they rapidly multiply. Thanks to Magnia's magic potion and the capacity of the moss to regenerate, it will take less than 2 years to restore this site. Iceland is a sanctuary for nature. The country boasts some strange species of moss. One of them even breathes. But is it actually a moss? The golden plover has a very special relationship with the mosses that grow on the Icelandic heath. This bird lays its eggs in the ground in a little hollow dug by the male. At birth, the chick's down mimics the moss in its environment. The golden plover's adult plumage is dynamic, but the chicks remain carefully camouflaged on the heath. In Vietnam, the mimicry is even more marked in the mossy frog. There are no soft, velvety feathers here, but a slimy, knobbled epidermis. When in danger, this amphibian freezes and imitates a bryophyte to hide from its predators. The fox is also a valued friend to a certain species of moss that only grow on fox excrement. Tetraplodon belongs to one of the most elegant moss families on Earth, but has a taste for feces and putrefaction. It is also capable of olfactive mimicry, giving off a perfect imitation of fox excrement odor to attract coprophagic flies. This is an effective collaboration with the insect, allowing the moss to spread its spores by proxy into the wild, a unique feature amongst mosses and a fine example of collaboration and co-evolution between species. It reveals an aptitude in mosses to adapt in order to survive, provided they do not run into any obstacles. Humans are hindering the spread of mosses and have declared war on them. In many countries, they are considered parasitic plants, associated with mold and decay. They eliminate the mosses with chemical herbicides, which can be toxic for the wider environment and even for humans. A researcher at the Sorbonne University in Paris may have found a formula that could change this approach. Emmanuel Baudouin is working on a patent for a natural herbicide.
Cette histoire qui est un petit peu inhabituelle, elle arrive dans un moment où la société est en recherche de solutions respectueuses de l'environnement. Et donc je pense que c'est une des raisons pour lesquelles elle a finalement intéressé autant de personnes.
The adventure began in 2017, when Bastien Ney, a chemist, asked Emmanuel Baudouin to work with him on a naturally occurring molecule, Radulanin A. It comes from Radula, a common moss found in our forests. They discovered that this molecule possesses amazing herbicidal properties.
radula, donc la mousse d'où est extraite cette radulanine, c'est parmi les plus anciens végétaux terrestres. Ce sont des végétaux qui remontent à peu près à 450 millions d'années. Cette radula produisant de la radulanine était présente dans un environnement dans lequel n'existaient pas les plantes à fleurs beaucoup plus évoluées.
Emmanuel Baudouin chose a tiny flowering plant as a subject for his experiment. Thale cress. It is considered a weed. He asked his team to mix the radulanin molecule from the moss with the samples of thale cress in a liquid solution. The objective of the experiment was to test the herbicidal properties of radulanin A on the cress plant.
Eh bien, ce qu'on observe, c'est un changement de couleur assez rapide de la rabette qui peut aller jusqu'à la disparition totale de la chlorophylle. Et donc, par ce biais, on distingue la mort de la plante et on va la voir très rapidement dégénérer à l'intérieur du puits. J'avais testé avant beaucoup de molécules qui provenaient d'autres origines et jusqu'ici, je n'avais jamais observé un résultat aussi rapide, aussi foudroyant sur la plante à fleurs. Pour le moment, c'est évidemment à l'échelle du laboratoire. Ce qui pourra se passer par la suite à l'échelle d'un champ, d'un jardin, ça, c'est une autre histoire.
It is an ironic twist that this moss could someday contribute to the elimination of other mosses. Even though we cannot explain why, it possesses the same devastating capacities as glyphosate. Mosses, long overlooked by science, are gradually yielding up their secrets, and new fields of exploration are opening up for researchers. On the majestic, wild Japanese island of Yakushima, the mosses communicate with the trees. The mountain is covered by a forest of 1,000-year-old trees and is home to the Yakusugi, giant cedar trees which are considered sacred. It is also a realm of mosses. A pilgrimage site for bryologists from all over the world. In this fairy tale undergrowth, inhabited by deer and macaques, the mosses absorb considerable quantities of water, which they redistribute to the roots of the tall trees. The thousands of species of moss thriving here still have many secrets to reveal. Some protect the giant cedar trees from pathogenic bacteria thanks to their antibacterial properties. Like guardians, they have a considerable effect on the habitat that they colonize. This antibacterial action shows just how much science could learn from these mosses in the search for new medicines. These tiny plants, too long overlooked, could play a pivotal role in unexpected fields of science. In one of Europe's oldest observatories in Copenhagen, astrophysicist Ufil Wies and his colleagues on the Space Moss program have genetically modified a moss. His goal is to study the moss's capacity to survive in the hostile environment on Mars.
When you do space travel, every kilo that you bring into orbit or to another planet is immensely expensive And if just the medicine alone for a 3-year journey where you want to make sure that the people are healthy and come back safe, you need so much medicine, so much food, so much equipment and supplies, so much of everything. And if we can make a moss that is capable of producing certain types of medicine, then you just have to bring a little patch of the moss that can produce penicillin or whatever compound you're after.
In the near future, moss could produce medicine that astronauts could cultivate on Mars. On the condition, of course, that Visa's genetically modified moss survives the Martian environment. So, how can the moss's resistance be tested on Earth? The members of the Space Moss Laboratory at the National Institute of Copenhagen came up with a solution. They designed a machine that artificially reproduces the Martian environment.
On Mars, you need something that's very, very harsh and resilient. Mosses can survive a lot of extreme situations. They don't grow very fast, but they just stick around when other things die. And that's something you need if you want to go to space. Okay, so we have the moss and the Mars chamber, and then we have the sluice here, which is the entrance to the Mars volume. And in here we can place the moss in the sluice. Then we can go over here, the sluice port. Get the moss into the main chamber. Close up that sluice port again, all the way.
When the airlock closes, the chamber becomes completely airtight. The moss then experiences a simulation of the extreme atmospheric conditions on Mars.
Pump in a lot of CO2 in order to simulate the Martian atmosphere. That's over here with a little knob. That creates a vacuum inside of the tiny chamber. So we have the Martian atmosphere in the whole chamber, and then we have a tiny volume where you also have the pressure or the lack of pressure. That's the UV lamp turning on. And then we have the Martian atmosphere. Inside the chamber we have the Martian pressure, the Martian radiation, the temperature, and if we also want Martian soil and perchlorates, we can put it under the sample that we put in to the chamber.
It is as if Joffiel's moss has been transported 70 million kilometers, and he can observe all the effects of the Martian environment on the moss plant.
And that's a very good simulation of Mars.
Joffiel's modified moss survived temperature swings found on Mars, which can range from plus 25 degrees to minus 120 degrees Celsius in a single night. The first stage of the research has been completed. NASA is interested in the Space Moss program and has contacted the laboratory. Joffiel is a candidate to join the European Space Agency and one day hopes to test his mosses in outer space.
So we think of the Earth as the blue planet, and we think of Mars as the red planet, but I think it would be so cool if in hundreds of years we would be looking up at Mars and thinking about it as the green planet, because mosses had covered the entire surface. It may or may not happen, but I think it would be awesome. But to me personally, I think traveling into space and going to other planets and becoming a multiplanetary species is just such a romantic idea.
For Jophiel, mosses might help open doors to interplanetary travel. These were the first plants to successfully colonize our planet. Could this scenario repeat itself elsewhere? In the course of evolution, mosses have acquired the capacity to resist extreme temperatures, pollution, and radiation. Understanding their versatility and resistance could lead us towards future discoveries and allow us to imagine new scientific perspectives. These magical mosses work wonders, and we are only beginning to understand their secrets.